Hello, Rian. I'm audible. Okay, so fine, guys. I think I'm audible, and yeah. So good evening, everyone, and let's start with the class. So today we are going to build a model. So let's try to build a model. So first of all, let's try to open up a new notebook. Let me share my screen. Yeah. So I think my screen is visible, right, to every one of you? Yeah. Okay. Fine. You're changing from trainer to fashion designer. Okay. So fine, guys. So I think in last class we were talking about a logistic regression, right? For a logistic regression, so maybe we can try to build a model, and we can try to understand how we can try to deal with this model building things, or how we can try to perform various different kind of operations that we have discussed in our previous classes. That's a whole idea, and that's a thing that we are going to implement. So anyone who is having any kind of a doubts, concerns, or maybe any kind of a questions with respect to logistic regression, by the way, anyone, any thoughts you have, or anyone who is not able to remember what we have discussed in last class? So last day I read somewhere that we should not call isolation as a classification problem. Actually, when I have started my class, when I have started my lecture, so I have given the statement that there are so many things, so many discussions you will be able to find out over internet, that we should not call this as a regression problem. So basically it's called as a classification problem, right? So, or maybe it's not. So the kind of a name, the way name is given to this logistic regression is not a correct one. So I think I have already discussed about it. It should be called as a logistic classifier, not as a regression, but yeah. So again, you will be able to find out discussions in a favor of this name, and yes, against this name. Only difference in login and sigmoid. So where to use a what? So see, sigmoid functions you are supposed to use whenever you are supposed to find out the probability. And from a sigmoid itself, so we are trying to derive what? So we are trying to derive a logit function, which will give you a value that in this side of a line or that side of a line, you will be able to get a data. So that's like a answer from my side. Multi-class will be covered later, right? So just wait for today's class. I think with respect to a multi-class, you will be able to get your answer, right? Okay. It is used for a binary classification problem, and in case we have a multi-class to predict, we use one versus rest. Yeah, so there is a concept inside a logistic regression you will be able to find, Sushant, that is something called as OVO and OVR, one versus one and one versus rest, right? So in case of a binary class classification, so we are going to use OVO, which is by default. And in case of a multi-class classification, so we are supposed to use one versus rest. But at any point of a time, if you will see, so we are actually doing a binary class classification over here, even in one versus rest. So rest of the classes will be one class, and then the class for which you are trying to do a prediction, that will be another classes. So that is a difference between OVO and OVR. Okay, so can you talk about a precision recall trade-off? Precision and recall, I think we are going to use it in today's class. FPR, TPR, sensitivity, specificity, understanding these terms are a little bit confusing. Yeah, I think you should take some time to digest it, and we are going to use it again and again. So now let's start ahead with the class. ROC and AUC are used only in binary classification. No, it's not like that. So you can try to use it even in a multi-class classification, both ROC as well as AUC. So where ROC is going to help you out with respect to finalizing a threshold values, and AUC is going to help you out with respect to finalizing a final model out of the n number of model that you are going to build. Now that n number of model can come from a heterogeneous model, means let's suppose I'm building a model for particular data set by the with the help of logistics, random forest, as well as decision tree, as well as XGBoost, and maybe a naive bias. So if I have to do a comparison in between these models, In that case, I can try to use AUC for sure. And we all know that AUC has been defined based out of what? ROC. Please focus on RMSE and MAE. I think there is no point of like focusing just on RMSE and MAE, right? I think we should look into this as a whole. Okay, so can you please ping something in chat? I want to test if copying is working or not. No issue, I'll ping you just in some time. Okay, so let's start with the class, yeah? And let's start talking about a code and everything. So fine, guys, I'm going to do like a common import. So import maybe, or I have a code. So directly we can try to import each and everything, right? So maybe we can try to import all of it in a single place. Yeah, and along with this, maybe we can try to import a pandas a profiling, which we are going to use, and pickle I have done import, no. So fine, maybe we can try to import a pickle over here. So these are the imports that we are supposed to do. So let me ping you this imports in my chat box. So please try to copy this import. So for the machine learning book that you have suggested, there is a briefing channel. If people are finding difficulty with the book, no issue. That's fine. Yeah. Okay. So I think you all are able to copy, right? I have already not able to copy. Okay. Okay. Able to copy. Some of you are saying that yes, you are able to copy, and some of you are saying that I'm not able to copy. Okay. Able to copy. Okay. Fine, no issue. So I think you can start typing, right? I'll give you a time. So as you can see on my screen, and we all are good with this import. So this is the same import that we have done even in our previous classes. So if you would like to do an import, even I have done the same thing. So like you can just try to do an import. I'll give you a time of maybe 2 to 3 minutes, right? So just try to like a type, and I will be here for next 2 minutes. Yeah. And hopefully, yes, my imports are going to work fine for me. Okay, so I'm using a Zoom app, by the way. I'm not using anything else. Yeah, so there is a suggestion. So those who are not able to copy, so if you are going to open up this Zoom in a browser, so instead of logging from a app, Zoom app, even I'm using Zoom app. So hopefully from a browser, you will be able to copy, and from a Zoom app, so there is some problem. But yeah, believe me, so there is no restriction that we have put from our side. No module name, Pandas profiling. I believe last time we all have used Pandas profiling. So this is our third or fourth time we are using Pandas profiling again in our classes, right? So those who have done this Pandas profiling things in last class, so hopefully these things will be available. If not, so in that case, you will have to do pip install Pandas profiling, and then it will work for you. Okay, so just try to type, guys, this one. Okay. So fine, is it done for all of us? Yeah, warnings are fine, Jairus. So you're not supposed to worry about the warnings. That's completely fine. Okay. So once we are able to do it, so once we are able to import all of these required libraries, so some of the libraries we are going to use, and I believe we have already done an import of all the necessary, unnecessary libraries. Some of the libraries we are not going to use, that is for sure. But still, yeah, that's completely fine. Now what we can do is, so maybe we can try to create a data frame over here. So we have to pick first of all data. So again, I will try to pick a very simple data set over here. So maybe I can try to write read CSV, and then inside that, so I'm going to take again one of the open source very simple data set, which we all can try to understand in a easiest possible way. So this is the data set link. Your data set is available at this particular link. So what you can do is, so you can try to paste, or I just pasted this data set in your chat box, so you all can try to copy it. Or maybe you can try to search maybe inside a GitHub, so you will be able to find out this data set. So just we have to import a data set. That's it. And again, the fun part is this data set is already available inside your dashboard in your previous class recording. So it's not like we are just going to use this data set just for now. So I think this data set is already available. If you will download your code base from your logistic regression part, it is available. But yeah, for now, so maybe you can try to use this link to import a data set. So once I'm going to use this link, and then if I'll show you data frame, so this is my data frame that you all will be able to find out. Now here, inside this data frame, and again, just wait until an end of this class, right? So I'll give you one a very impressive data set on which you can try to work, and that is from a multi-class classification. So I have already prepared a problem statement and a data set for all of you, so which I'm going to assign you at the end of this class. Okay, so this is a data set that we all have done as an import, right? And yes, so if I'll try to understand this data set, as we always do, right? So this is a data set which talks about that whether person is diabetic or person is not diabetic. It depends upon a different kind of attributes, or depends upon a different kind of readings that we have inside our data set. For example, pregnancies, glucose, blood pressure, or maybe skin thickness, insulin, BMI, diabetes, pedigree functions, age, outcomes. So these are the attribute which is given to me. Now, some of the attribute is going to work as a X, means your feature, and some of the, or maybe one of these attributes are going to behave as a labels, and we are trying to solve a classification problem. So we all know, so in case of a classification problem, I will be expecting for sure maybe some sort of a classes 1, 0, or maybe like a B, this kind of a classes I will be expecting. So fine, this is a very straightforward data set, and we all can just look into it, and we all can try to understand this particular data set. More definitions if we are expecting, right? So if we are expecting more detailed descriptions about this data set, so again, more detailed descriptions of this data set we all can get easily. It's like a, basically it's an open source data set, so it's not that tough to get information about each and every attributes or each and every rows that we have. Anywhere we can get this information, anywhere we can try to check that what is the meaning of this entire column set that we have given to me. Easily we can try to figure it out, right? Okay. So here, if we have to find out that whether a person is a diabetic or person is not a diabetic, so here is a column which is given to you, an outcome column, and we can try to consider this column as a Y column, or maybe this column as a label column, where labels are given to you. Now, this labels 1 and 0 depends upon this multiple factor. So this is a first observations that we have. Again, this is the first observation. I'm not saying that exactly this is going to help you out to find out whether person is a diabetic or person is not diabetic. But yeah, it looks like these are the feature which is given to me, and maybe based out of that, I will be able to predict whether person is a diabetic or person is not a diabetic inside this one. So we have a multiple features, and if you will try to observe a label part, if you will try to observe this particular column, outcome column, so we have a binary data set over here. So we are actually looking into a binary class classification in this particular place. So hope this part is clear to everyone regarding a data set, right? So there is nothing much that we have to understand over here. So it's a very simple, straightforward open source data set that we have taken, so that I will be able to do some sort of experiments based out of the learning that we had done in last class, right? In total, so there are 768 number of records that we have available to us, 768 number of rows which is available to us, or 768 number of instances that is available to us. Now, what we can do next is, so maybe we can try to perform some sort of a EDA, or maybe we can try to understand that how this data set is related to each other by doing what. So what I should do. So let's suppose if I have to find out some sort of a relations, or maybe a basic understanding about a relationship between a data set. In that case, what I'm supposed to do. So I think we all know about it, right? So we all are aware about this particular things, that what we are supposed to do. So maybe we can try to call profile report over here, and maybe we can try to pass our data frame. Again, very, very simple, right? So because we are already doing an import of a profile report in this particular place, right, from a pandas profiling. So it's completely fine. I can try to pass my data frame over here inside a profile report, and it will take some time, and it will generate some of the statistics. So generally we do like a data frame dot head, data frame dot tail, data frame dot describe, data frame dot data types, data frame dot columns. No need to do all of those kind of things. It's completely fine. Pandas profiling is going to work for me, and in a beautiful way, I will end up getting the complete reports, including an overview. So overview wise, number of the variable is 9. Yes, I'm aware about it. Number of the observations or number of the records is equal to 768. Yes, we are aware about it. Missing cell is equal to 0. So we don't have to do a null value validation, or maybe we don't have to do a null value imputation over here. So there is a 0% of the missing cell, right? Total size in memory. So again, size is very simple and very small. Average record size in memory, again, so very small, right? So 72 bytes, one record is trying to take this much of like a space. And numeric data set wise, so we have a total number of 8 columns where we have a numeric data set, and in one column, so we have a categorical. So yes, again, it's completely visible. So this is the categorical 101010. So these are the categorical value that we have over here. Now these are the just a very, very basic observations that we have over here. Now column wise, if I'll try to understand, right? So we have a multiple columns, right? So we have like a pregnancies column, and here, so total distinct number of pregnancies are 17. Different numbers is given to me. Missing value is equal to 0. Zeros are like there are some of the data values inside a pregnancies column which is having 0 values over here. Average of pregnancies is 3.84. I think it's not relevant, right? And it is showing me that it's a highly correlated with the age, highly correlated with maybe again age it is showing. So again, if I'll try to click on toggle details here, I will be able to find out more informations about this one. So what is a minimum value which is given to me? A 5th percentile, quartile 1, median, quartile 3, 95th percentile. What is the maximum value? So this data set is ranging in between 0 to 17, it seems, right? Interquartile range value is equal to a 5. The standard deviation of the data set is equal to 3.36. So it simply says that my data set may be maybe, again, I'm not sure about it unless and until I will not look into the graph, but it says that yes, standard deviation is equal to 3.36. So there is a chances that this data set is normally distributed, but maybe not a standard normal distributed, because in case of a standard normal distribution, so for sure, standard deviation is equal to 1. So this is something that I will be able to find out. Coefficient of variance is equal to 0.87. So if we are talking about the relations, kurtosis value is equal to 0.159. Average is equal to 3.84. Again, we are able to get it, right? Monotonicity is, it's not a monotonic data set that we have. Now, maybe I can try to look into its histogram. So if I'll try to look into a histogram, so does this data set looks like a normally distributed data set? No, right? So this data set is not at all a normally distributed data set. And again, for sure, this data set is not available in a form of standard normal distribution. So again, this data set is kind of skewed data set, I can say, right? So maybe on a right hand side, so it is trying to skew itself. And common variables, so these are just a distribution of the variables 1, 2, 3, 4, and different numbers is given to me. Now maybe I can try to look into a glucose data set, right? And here is a graph. So can I say that this glucose data set looks like it's a standard or maybe normally distributed data set? Yes, a glucose column, it looks like, right? Maybe in a very first place. So it looks like that, yes, this data set is normally distributed. So this is what a histogram is going to suggest us. Now I can maybe try to look into skin thickness, right? So again, this data set looks like this one is, I would say, normal distributed data set. Yes. So if I'll go and if I'll try to click on this one, so yes, there are some outliers, but this whole data set looks like it's a normally distributed data set that we have. Now, if I look into an insulin column, so again, I will be able to find out similar kind of a statistics. So where this data set looks like a little bit of skewed in a right-hand side direction, a little bit, not much, right? Again, if I look into a BMI column, so again, inside the BMI column, we have a almost approximate normally distributed data set. Now, if I'll look into a diabetes prediction, so toggle detail, and maybe we can try to look into a histogram. This data set is again a skewed one, right? This column is again skewed towards right hand side. Now, if I'll try to look into a age data set, if I'll click on histogram, so this again data set looks like it's skewed on a right hand side direction. And outcome, so this is our categorical column that we have, right? So categories wise, we have in total like categories 500 plus 268, and this is a total distribution of categories, right? So we have a total detail or total data about a person who is having a diabetes is equal to 268, as you can see inside a pie chart, right? So it's been represented by orange color, and we have a total 500 number of records where, so we have a data set which is not having any kind of a diabetes at all. So this is something that we are able to find out. This is just basic informations I'm able to find out. Now, if I'm looking for maybe a graph of one versus rest, so maybe I can try to even draw a graph, because this is just a very common like a graph that I will be able to get. But as I'm not working on a linear regression problem, so maybe I don't have to like worry about this relational graph or maybe this kind of a scatter plot. Now, if I look into a correlation, so what does this graph says? So any idea? I think in last class we talked about it, right? This Pearson coefficient. So what is the meaning of this graph? Any idea? Anyone who can explain? So it is going to tell you that, okay, so whether your data set is highly correlated in between or not, right? Because if there is a multicollinearity, can I say that in that case, I'll have to remove my columns if there is a multicollinearity? If there is no multicollinearity, so in that case, I can try to keep it. So this result you will be able to get from a correlation coefficient, or maybe you can try to plot a Pearson graph or Spearman, or maybe Kendall's, or maybe Fick test you can try to do, or maybe you can try to perform a VIF, right? So variance inflation factor you can try to find out, and even out of that you will be able to find out a same thing, where variance inflation factor is nothing but 1 by 1 minus r square, right? And if it is greater than 10, so in that case the data set is highly collinear to each other. So maybe we can try to find out VIF as well, and we can try to perform these kind of operations. So fine. So yes, correlation reports, we are able to get missing value wise. There is no missing values that we have. It's completely fine. This is the sample data set that we are able to get. So maybe head reports and tail reports we are able to get. So according to our very first observations, we are able to figure it out that, okay, so there is no multicollinearity that we are able to find out in general, right? So again, it's not tending towards -1 or +1 a lot. So maybe there is no multicollinearity, but I will be able to get an exact answer. So once I will try to print a VIF of each and every VIF score of each and every feature. In that case, I will be able to know that, okay, fine. So whether there is an exact multicollinearity or not, maybe that will give me a correct decision. But yes, just by looking into this graph, like this Pearson graph, it looks like there is no multicollinearity. That is one of the things. Now, second thing is that, yes, there is some skewness inside our data set. The third observation that we are able to find out over here is that there is no null values that we have. There is like no null values, or there is no missing values that we are able to find out. Data set is skewed a little bit, but still that's completely fine. There is no null values that we have in this particular place. So any other observations that we are able to find out? So Lalit is saying that age and pregnancies have a correlation. So maybe we can look into this. So age and pregnancies. Again, it looks like it's below 0.75. So it's completely fine. It's not crossing 0.9. So it's completely fine. I can say that, no, it is not having a correlation. So any other observations that you are able to find out? Can you tell how skewness is shown? So I think we have seen a histogram, right? So now in this histogram, it's very clearly visible that my data set is skewed, right? Can I say this is the skewed data set? Yes. So this is how I will be able to find out that whether my data set is skewed or not, without even looking into a values. Maybe I can look into the values and then I can try to figure it out. But yeah, just by looking into a graph, so I can try to observe. Glucose and outcomes are slightly positively related. Okay, so maybe we can try to check that how glucose and outcomes are related to each other. So maybe glucose and yeah, so glucose, and you're talking about the final values, outcomes. But yeah, outcomes we will not be able to get over here because it's not going to print categorical values. After the skewness analysis, we should convert to normal distribution every time. So yes, it is advisable to convert these things into a normal distribution. That's always a better idea. Okay, so these are some of the observations that we all are able to find out. Now, what we are supposed to do next? So some of the data set is skewed, some of the data set is not skewed. So maybe, and yes, one more observation. So here we have some of the data set. So where we have a zeros values, right? So if you will look into this report, right? So missing zeros is equal to 0 inside a age column. So maybe I can try to look into BMI. So there are 11 zeros that we have. So 1.14% of our zeros, which we have over here. If I'll talk about insulin, so there are 48% zeros values are available over here. If I look into a skin thickness, there are 29% of the zeros values, which is available over here. If I look into a blood pressure, so there are 4.6% of the zeros values, which is available over here. If I look into maybe glucose, so what is the zeros? It's a 5. So it's a very, very less, 0.7% of the zeros values, which is available over here. If I look into a pregnancies, so there are 14.5% of zeros, which is available over here. So we have so much of zeros. We don't have a null values. That is completely fine. So null values means NaN, right? So we don't have our NaN values over here, but we have a very, very high amount of zeros, which is available inside my data set. So maybe those informations is not been captured. right? And maybe because of some issue with a device which is capturing this entire like a record, so failure of the devices, so it has like replaced these things as a zeros. There is a chances, there is a possibilities, because if I'm talking about maybe a glucose, so there must be some glucose values. If I'm talking about like blood pressure, so for sure if you are going to check some of the person, right, so you will be able to find out some blood pressure value, right? It's not like a person, so in a person you will not be able to find out a blood pressure values, otherwise person will be dead, right? So can I say over here that maybe because of a device failure, right? So because of the device failure, this zeros is not been captured. So in that case, what we are supposed to do, again, I'm able to talk about these things after looking into a name and after looking into informations about a data set. So let's suppose I understand the blood pressure, right? So if I understand a blood pressure, only in that case I will be in a position to make a statement. Otherwise, I won't be able to make an statement at all. If I'll talk about a BMI, so where is my BMI, by the way? Skin thickness is there, insulin is there, BMI is there. Again, so for sure, so BMI is not going to be zero at all for any living person. If I'll talk about a glucose, let's suppose, so where is my glucose value? So if I'll talk about glucose, blood pressure, glucose, right? So we have these many zeros values. Now glucose level can't be a zero at all in any circumstances. If I'll talk about insulin, so again, insulin is, or maybe I can talk about even a skin thickness. So skin thickness won't be equal to zero at all for any living species. If I'll talk about insulin, so again, there are so many zero values, but yes, there will be some readings you all will be able to find out if you are going to measure a insulin. So these are the columns. Apart from this, even in pregnancies column, we have a zeros, but we are not supposed to worry about it. There is a very high chances or possibilities that yes, device has captured that record or that reading as a zeros. Everyone can't be a pregnant, right? But if I'll talk about insulin, if I'll talk about a blood pressure, if I'll talk about a BMI, if I'll talk about a glucose, if I'll talk about a insulin, so these columns values can't be a zero. If I'm trying to capture this record for any living human being, right? Yes, otherwise person will be dead, right? So first of all, I'm trying to understand what? I'm trying to understand a feature and a data set and a relation. So it's actual meaning, or I can say it's business meaning I'm trying to understand. So it's not like I will just start doing something out of just a random walk, right? So we will not start doing this kind of a things. What we will do is, first of all, try to understand a name, right? And its business relation. That's the reason. So we have taken this very simple data set so that, because we all understand this BMI, glucose, or maybe a blood pressure, insulin, or maybe a skin thickness, right? So it's easy to understand for all of us. So maybe this knowledge is very, very important. So whenever you don't have any idea about a column name, so in that case, or maybe what this column is, or why we are taking this particular column or this particular feature, so in that case, you are supposed to connect with your functional team and you should ask this question, or maybe with your client, that okay, so what is the meaning of this particular column, or how you are capturing and how significant this particular column is. So these are the certain questions that you are supposed to ask to your client or maybe to your functional people, which will be available by default whenever you are working in any of the project. That's completely fine, right? I think we are like a good till this particular point. Yes, everyone? Yeah. Now what we can do is, so once we are able to figure it out that there are so many zeros where zeros are not supposed to be there, right? There are so many zeros. Now let's do one thing. So what I will do is, so maybe I can try to update these zeros, right? So maybe we can try to update these zeros by what value? So maybe by median, maybe by mean, I can try to update these values. Possible, right? Let's do it then. So what we will do is, so for a BMI column, for a blood pressure column, for a glucose column, for a insulin column, for a skin thickness column, we are going to update it. Now, if I'm going to update it, so what we can write over here? So maybe I can write that data frame, BMI, I believe, right? Data frame BMI is equal to what? So maybe I can try to write it down, data frame and then BMI column dot, right, replace what? So replace all the zeros. Replace all the zeros with what? So maybe data frame of like BMI average. So with BMI average, I can try to replace it. So maybe I can try to write mean over here. Is it fine? REPLACE. PLSCE. Okay, fine. So maybe we can try to write this line of a code by which what will happen. So it will try to take an average of the BMI column and it will replace all the zeros by its average. Is it fine? Yes. So now if I'll, so this is like a completely fine. So yes, it is going to work for us. So we are just trying to update our BMI column. Now what is next? So maybe we can try to work on a glucose column and blood pressure column, insulin column, and in the similar way, and maybe we can try to achieve a same thing. So data frame dot columns, just for my reference, I'm going to print it. So data frame, and then I can try to work on maybe a blood pressure column. So this data frame, and then maybe a blood pressure, right? Dot replace, and then replace what? So replace zeros, replace zero with what? So data frame of, and start typing, guys, blood pressure. Okay. So mean of this blood pressure. So mean of this blood pressure. Now this is done. Now a next column which I can try to pick and choose is maybe insulin column, right? And data frame of maybe insulin column dot replace with what? So replace REPLSE, replace, so replace what? So replace zero with data frame of maybe insulin of maybe a mean. That is done. Now maybe we can try to work on glucose. So glucose over here, data frame of maybe a glucose, yeah, dot replace REPLSCE, replace zero with data frame of maybe glucose of a mean. Done. Now maybe we can try to work on skin thickness. So skin thickness, and I can try to do data frame of skin thickness dot REPLSCE, replace zero with what? So data frame of skin thickness dot mean, right? So maybe in this way, I'll end up overriding all the values which is having a zero. Yes, it's fine. You can try to write a code maybe in your way. So you can try to take iterate over to a columns, and then one by one, or in an automated way, you can try to like do it by using maybe a for loop or something, right? That's completely fine. So in this way, you won't have to write like these many number of the lines of the code. There is always a possibility to do an optimization, a very simple thing, right? Okay. So is it a good idea to replace with mean every time? In general, it's a good idea. You can try to replace these things with a median as well. That's completely fine. But as your data set is skewed, so you can't rely on a median and a mode. Yes. In many of the data set, we all have observed that your data set is skewed. So it's always a better idea to go ahead with the mean instead of going ahead with these things, right? Okay. So now, can we replace these things with the nearest neighbor? In general, no, you are not supposed to do it because you don't know about the pattern of the data set. If you are aware about the pattern, if you think that it is following the similar kind of a pattern, only in that case, with the nearest neighbor, you are supposed to do a replacement. But every data set is independent of each other records. In that case, that logic is again not going to work. And maybe you will end up generating a wrong outcome. Okay, now what we can do is maybe we can try to again generate a profile report of a data frame. So now this time we have replaced every zeros, right? We have replaced all the zeros with its mean. So now let's try to look into this data set and let's try to check. So whether still we are able to get some sort of a skewed data, or we are not able to get some sort of a skewed data set. So I think in this way, we will be able to get an answer. Okay. So here is again a report which I'm trying to generate. So pregnancies, we were not supposed to touch this part because uh, in pregnancies column, there is a possibility that we may find out a zeros. That's a good idea. Now, if I'll talk about a glucose, so yes, in glucose, I think we have removed a zeros. Now, if I'll look into this histogram looks like a normally distributed one. So last time, pregnancies has 111 zeros. That is completely fine, but that's the reason. So I told you, right? So first of all, we are trying to understand a business meaning of the data set, and pregnancies column can have a zeros value. So that's completely fine. It's not like unnecessarily we will try to do this kind of a treatment, right? But approximately this one is a normally distributed. So approximately again, all the time, so you are not going to get an exact exactly normally distributed data set. Skin thickness, so yes, it looks like zeros are equal to 0, right? Last time there was a zeros. If I look into histogram, so again approximately this looks like a normally distributed one. That's completely fine. Maybe if I'll talk about a BMI, so BMI, I think we have done the replacement, right? Replacement of zeros. So yes, our data shape has changed a little bit. Now, if I'll talk about diabetes prediction, I think we have not done anything on top of the diabetes prediction. If I'll talk about age, we have not touched age at all, right? And there was no zeros for sure. So these are the things that we have in our hand. This is something that we are able to draw, that we are able to plot in this particular place. So find zeros wise, we are able to remove it. Once we are able to remove this zeros thing, right? So now what we can try to do is, so maybe we can try to find out, right? So maybe we can try to find out that whether we have an outliers or not into our data set. Because again, if there is an outliers into my data set, so I have to do a treatment and maybe I'll have to remove it. And because of the outliers, maybe I'm receiving a skewed result. There is a very high chances, or there is a possibilities. So if we have to find out the outliers, what I should do in that case? See, zeros we are able to handle. So this is the first level of treatment that we are able to do. So after performing some sort of a EDS operation, which was very, very easy now for us. Uh, so analysis part wise, right? So we are able to do an analysis. But the next thing that we are supposed to do is that we are supposed to, right? So we are supposed to find out that whether there is an outliers or not. Zero treatment, we are able to do it. There is no null value, so we are good with it. There is a skewness into a data set. So if there is a skewness, so for sure we have a outliers. If there is no skewness, in that case, I can clearly say that there is no outliers. But yes, we are able to find out some sort of a skewness into our data set. It simply means that we have an outliers. Now we are looking for an exact things that, okay, fine. So what is the volume of the outliers that we are having? So maybe we can try to perform multiple different kind of operations, but box plot is going to give me a result, right? Or box plot is going to tell me that, okay, fine. So what is the outliers that we have? So let's try to do a box plot operations over here, right? So now if I'll try to do a box plot, so I think I have done an import for a PLT. Yeah, so matplotlib, pyplot, and PLT. Fine. So if we have to do a box plot, so maybe we can try to say, so PLT dot subplot, and we can try to define a complete subplots, I believe. Okay. So we can try to define a figure size, fig size, and maybe 10 cross 20 I can try to take. So this is the boxes. Now fig and axis, which is required. So maybe I can try to take out from here. Now SNS dot, I can try to call a box plot over here. And inside that box plot, I can try to give data is equal to my data frame and what in all things is required. So data set is given, hue data is given to me. Fine. And now I can try to give axis is equal to axis that we have printed. and then execute. Fig size is not defined. So fig size is equal to, yeah. So this is a plot, this is a box plot that we are able to get. Maybe we can try to stretch this fig size a little bit. Okay. So now this is a plot, this is a box plot that we all are able to see, right? A very simple way. So we all are able to see a box plot. So are you able to do it, guys? Yes. So this is a very simple box plot that we are able to do. Now, if you will start looking into this data or start looking into this graph, so in what in all like a columns, you are able to find out an outliers out of this box plot. So can I say insulin is a column which is having so many outliers, right? Very clearly visible. Skin thickness, yes, we do have outliers. Blood pressure, a little bit of outliers we have in pregnancies column, a little bit of outliers we have age column, we have a little bit of outliers, BMI column, so we have a little bit of outliers. So yes, we do have an outliers in some of the columns, and maybe we'll have to do a treatment for all of these outliers. So there are multiple ways again to treat with an outliers, right? There are multiple ways by which I will be able to handle this entire outlier things, right? So anyone who can suggest me how we can try to do a treatment for an outliers? Yeah, there is no outliers for a glucose that we are able to find out. That's true. Yes. So anyone? Okay, scaling by using IQR, Z score, IQR, using IQR, log transformations. Yes, log transformation is a possible way by which we can try to remove an outliers, or maybe we can try to bring down a data set into a low level, removing outliers, IQR. Okay, so fine. What we can try to do is, so maybe if there is an outliers, right? So outliers means what? Maybe on a upper side or maybe on a lower side, right? So there will be some values which we are not expecting, but it is available inside my data set. That may be the possibility, right? So we are not expecting those data set, but that data set is available. So maybe we can try to remove those data set, right? So maybe we can try to remove those data sets, certain percentage of the data set if we are going to remove in that way. So yes, I will be able to remove an outliers. There is a chances, there is a possibilities, right? So let's suppose in my insulin column, so I have like a so much of outliers. So maybe I can try to remove 5% of the data set from a quartile, right? And yes, so I can try to check whether I'm able to remove some of the outliers from my data set or not. So fine, here we can try to create maybe a variable called as Q, right? So that I will be able to remove, and I can try to take something called as data frame, because I think data frame is something which is available, right? Insulin dot quartile. So QUANTI, yeah, quartiles. And maybe we can try to remove a 5%, and we can try to keep a 95% over here, right? So we can try to give this quartile is equal to 95. That's completely fine. Now what we will do with this one? So we can try to use these things for filtering out the results. So data frame new we can try to build, and data frame new is nothing but, so we have a data frame. Now out of this data frame we are trying to apply what? So we are trying to apply a filtration operation, right? So insulin, and here insulin, and we are selecting only those data which is having a 95% of the results. So here is the things, df underscore new, if I'll try to print, right? So we have a 728 into 9 column. Now if I'll try to plot this data by using a same graph, we are just keeping a 95%. So if I'll try to plot this data, and here, so df underscore new, right? Now let's try to see. So I think this graph had changed, right? A little bit. This graph has changed. Yes, as compared to the previous graph that we were able to get for insulin, I think this time this graph has changed a little bit. Okay, what I will do is maybe I can try to do another experiment. So I can try to increase this one. So maybe 90%, right? So 10% I'm trying to reject DF new, right? Now, can I say that again, this graph has changed a little bit, right? Again, this graph has changed a little bit over here. And here, if you will try to observe, so can I say that we are losing a data set in this process? So we are removing some of the data set. Yes. So we are removing a complete rows or complete record in this particular place. Maybe I can try to do one more things over here. So I can try to keep just a 70%. Let's suppose, let's try to experiment these things with a 70% of the data. Now in 70% of our data, okay, so insulin is like it has like a changed completely, and it is going to affect other columns as well. Previously, I was not able to get this outliers inside a glucose column, but now this 70% of the data set is showing me a report that, okay, fine. So there is a outliers that we have over here, right? So maybe in this way, I can try to run a multiple experiments, and then I can try to remove some of the data set or some percentile of the data set based out of a different columns. And yes, in this case, we are going to lose our data. It's not like we are not going to lose our data, right? So we are going to lose our data for sure. So that is completely fine. That is not an issue at all. We are going to lose our data. But the whole idea over here is we have to decrease an outliers as low as possible. We are supposed to keep our outliers. Now, so quartile 70% means what? What is the meaning of 70%, 90%, 95%, which I'm trying to give over here? So I think we talked about this box plot, right? We talked about even a skewness. So quartile, this one is nothing but, so it is going to keep just, so let's suppose I'm plotting a graph, right? Or this box plot if I'm trying to do. So how I'm able to plot this particular graph? So can I say that I'm trying to take a minimum, maximum, IQR, and then above IQR, right? So we are just trying to remove those data set which is available on a tail position. This is something which I'm trying to do in this particular case. So 30% of the data set I'm losing over here. So if I have written quartile 70%, so I'm just trying to keep a 70% interquartile range of the data, and then 30% of the data set which is available on above upper quartile. So I'm just trying to lose it, or I'm just trying to drop it. This is the meaning of this one, right? So we are just trying to drop those data. If I'll try to show you a definition of this one, so return a value at the given quartile over a requested axis. So if I'm going to write quartile is equal to 70%, so above a 70% quartile range, it is going to give you a, so it is going to remove the data, and below that, so it is going to keep a data set. This is what it means at any point of a time as per even a definition. So is this things is fine to everyone? What is the meaning of quantiles? Yes. Okay. So I'm just losing 30% of the data set, and very clear explanation you will be able to see. So what is the total number of record in my original data set? 768, right? And what is the total record that we have as of now? 536. So we are losing some of the records over here, and the 768 minus 536, if you will do, so that number is going to tell you it's a 30% of 768, which was the original number that we had, right? Okay, so now just try to do these things in a respective process. So I'll not try to do in this way. So maybe what we can do is, so one by one, we can try to look into that. So first of all, I'll try to lose some of the data set from pregnancies column, because there are like a minor outliers that we have over here. So here, let's suppose I'm going to write a pregnancies column, and I can try to lose as per our previous experiment. So I can try to lose maybe a 98% of the data set from the pregnancies column. Sorry, not lose 98%, keeping 98%, losing 2% over here. Okay. So now if I'll try to show you df underscore new. So Okay. Yeah. So we are losing 2% of the data set, right? And this is something that we are able to get. Maybe I can try to plot this graph and let's see. So whether we are able to remove something out of a pregnancies column or not, right? So can I say that now pregnancies column is clean after removing 98% of the data? So after keeping 98%, pregnancies column is clean now, right? So we don't have any kind of outliers. If you will look into the previous graph, right, the original one. So this is the original graph that we had, and we had some outliers inside a pregnancies column. So maybe I'm able to remove it. Yes. Okay. So once we are able to remove this one, so maybe we can try to look into some other graph, right? So maybe I can try to look into a BMI. Again, it's experimental thing. So after which one you are supposed to work on. So these are the experimental things, and you have to experiment. Then only you will get to know that, okay, fine. So from which column I'm supposed to remove first and second and third. So this is how this things is going to work. And here, so for sure, we are losing a data. There is it's not like we are not losing a data set, right? So we are supposed to lose again in a certain ratio. It's not like we will end up losing all the data set and all the meaningful information at the end of the day. So we are dropping off some of the like a row or some of the records, I believe. Now here, what we can do is, so maybe we can try to write down. So from pregnancies column, I'm trying to lose it. Now I can try to write that, okay, fine. So I can try to create a quartile range for a BMI. There is a possibility for BMI. So dot quantile. And out of this, maybe I would like to lose 1% of the data, right? So I can try to write in this way that a BMI and data frame underscore new, same variable I'm going to override. And here, so I can try to write data frame underscore new, because we can't take a data of DF as of now, because we have to work on now a new one, whatever in whatever data frame where we have already lost some of the data with respect to a pregnancies column. So fine, we can try to write down DF new and DF underscore new, and maybe BMI is lesser than this queue, our latest queue that we have created. So yes, in this way, again, I will lose some of the data set, and let's try to understand a graph. So I think last time, right? So when we were looking into this BMI, so there was so many outliers. This is the original graph, right? And this time, so when I'm trying to look into this graph, so now we have a very less outliers. Yes. Why it is affecting others? Okay, so it is affecting others because you are dropping a complete record, right? You're dropping complete record. So it's not like just this column is losing a data, other columns are losing a data, right? So it is affecting the final record. That's the reason. So I'm showing you this number, that it is affecting the complete record. So it is deleting the complete record in itself. So for sure, if you are deleting some of the records from all the data sets, so nature of the data set will change, right? The way it is going to show you the final outcome is going to change. So that's the reason. Okay. Now, so what we can do is, so we can try to perform same operations, this similar kind of operations, maybe with respect to skin thickness. So let's try to perform that operation with respect to a skin thickness and skin thickness. Let's try to do that. And again, so we can try to lose maybe 99% of the data. Then again, I lost some of the data set. And let's try to check so how my skin thickness looks like. So again, this is my graph. What was my original graph? So skin thickness original graph, or maybe I can plot it there itself. Yeah. So this was the original one, right? The skin thickness. We had a skin thickness, right? This is the one after removal of 1% of the data set based out of the skin thickness quartile range. Now, what we can do is, so we can try to again lose some of the data set for maybe insulin. right? So now it's an insulin on which we can try to work on. So no issue. I can try to just replace insulin, and here is insulin. Okay, and lost some data, and let's see what we have. So yes, a graph has changed a little bit, right? So graph has changed a little bit, and we are able to see some differences. So this was my original graph, and this is my new graph. So yes, this was my original, and this is my new. Upper quartile has increased a little bit, but still we have outliers. There was so many outliers which was available, so it is not affecting a lot. So maybe for insulin, I can try to increase a percentage over here. Yeah, so lost almost like a 5% of the data set, and this has decreased. Outliers has decreased in that particular case. Now maybe we can try to lose certain set of the data for maybe a diabetes pedigree function. So diabetes, okay, I think DF was something, and then not supposed to do it. Everything should happen with respect to DF new diabetes pedigree function. Okay, so again over here, this treatment is done. Now maybe we can try to, and what is the total amount I have lost? 95, 998 is fine. Otherwise, we are losing so much of data set over here. Then we can try to work on maybe age part, and let's see. Age column, 99% is good. 95, 99, 98, that's good. Okay, so age part, fine. Age part is good. Previously, we had this range which was very, very small. Now we had a certain range, but still we have some outliers. We don't have a too many outliers over here as compared to my previous result. So we were having like so many outliers or dense outliers, you can say. But if you will check our graph now, so we don't have a dense outliers as such a lot. So maybe we can try to increase this number, the number of the data set that we are trying to lose. And in that way, we can try to do a treatment. That is also a possibilities. Now, what I will do is, so I can try to generate a profile report again, and I can try to call DF new over here, and let's see. So whether we are able to get our normally distributed data set or not, or approximate normally distributed data set. Maybe in spread of insulin is large, yes, Ketan. So this one is large. Okay, so now let's try to observe our columns one by one. So pregnancies, okay, still skewed, which I'm able to find out. Blood pressure, approximately normal distributed. Skin thickness, approximately normally distributed. Insulin, it is normally distributed. There are some, yeah, approximately normal distributed data set we have. So there are very few data set which is showing you, or maybe just one kind of a data set which is showing you this outlier relation. So that's completely fine. We can digest it. BMI, so yes, this is a normal distribution data set that we are able to find out. Diabetes prediction, so maybe I can try to do a little bit more a treatment over here, because this data set still looks like skewed to me, right? If I'll talk about this diabetes prediction data set, yes, okay. Now, so if I'll talk about age over here, still skewed, yes. Now, if I'll, yeah, so these columns, so there are some column which we are able to fix, and there are some columns which maybe I'll have to work and I'll have to do something else by which I will be able to perform this kind of operation. So the whole idea over here is to show you one of the way by which I can try to do an outlier treatment. So that if someone is going to ask you a question that how you were removing an outliers. So maybe you can say that by experimenting with a quartile ranges, right? So we were trying to remove some of the outliers, right? And again, you can try to write one of the beautiful functions. Rajesh has already written this function, right? So Rajesh has written this particular function. So just by using this function, so I think you will just have to pass a data, and then you will be able to do a outlier treatment. So yes, this kind of a functions you all can try to use for sure. So whenever you are building your own library, please share. So it will be okay. Let me bring this things to all of you. Okay, fine. We can remove an outliers with an average value of that column. See, so for sure, you are supposed to find out the mean. Then you are supposed to find out the standard deviations, and then whatever data set which we are able to get, maybe beyond 2.5 or approximate close to 3 standard deviations. So maybe we can try to remove it. So that is also a kind of a calculation that you can establish to remove an outliers. But removing an outliers or dropping those data set is not the only way by which you will be able to normalize or standardize a data set. There is other way as well. So little bit of treatment we have done over here, and little bit of treatment maybe we can try to do by using some sort of a transformation, maybe a log transformations, maybe a square root transformations, maybe by using a standard scalar concept. So we can try to use it. So there is a chances to perform even these kind of operations in a later stage. So it's not like you are just supposed to rely on this one. It's completely fine if you can try to depends upon something else as well. So a little bit of treatment from here and a little bit of treatment by using some of the other processes. Now what we can do is, so maybe we can try to take this data frame. So data frame new that we have, so data frame underscore new that we have, and we have these many columns. So maybe at this stage, we can try to separate this data into a X and Y. So how we can separate this data into X and Y? So Y wise, I think a df underscore new, and then we can try to take what? So we can try to take only a outcome column. I think this is my Y. Agree? This is my Y. It's completely fine. Now here, if I have to create my X, so in that case, what I will do, so maybe I can try to call a data frame underscore new, and data frame underscore new, maybe dot drop, and we can try to drop what? So we can try to drop a column called as outcome. Okay, so this will be my X over here. So this is my Y that I have created, and this is my X that I have created over here. Very simple, right? So X and Y. So after doing certain sort of a treatment, so I'm able to separate X and Y in this particular place. Now, once I will be able to separate this one, and we have an idea that our data set is not like a skewed, or maybe my data set is varying in between different ranges. So if I'll try to observe this data, so my glucose is varying again in between a huge range. Minimum and maximum is very huge. And same report you will be able to find out even from here. So what is our total ranges in between your data set is moving. So for each and every column. So if I'll talk about maybe a insulin column, so you will be able to find out like minimum value and a maximum value. So minimum is 15 and maximum is equal to 291. It's ranging in between a very high ranges. Now, if I'll talk about maybe a BMI, I can try to click on toggle detail, and then minimum is this one and maximum is this one. So in between certain range, it's fluctuating. If I'll talk about a diabetes predict rate, so in that case, again, my minimum is 0.078 and my maximum is 1.478, approximately like 20 times than this one. Now here, if I'll try to check toggle details and statistics. So here, what is my minimum? Minimum is 28. What is my maximum? Maximum is 66. So my data set is fluctuating, right? A lot, or my data set is varying in a different scale on a different ranges. So if that is a case, what we should do? So can I say that if my data set is fluctuating a lot, so in that case, I'm supposed to call what? I'm supposed to call a standard scaling. Yes, we are supposed to call a standard scaling, right? So we are supposed to call a standard scaling, and maybe so I will be able to reduce this fluctuation. That is the whole idea behind using a standard scaler. So it's not like blindly we are supposed to use standard scaler because everyone is using it, right? So okay, we are going to use a standard scaler over here. So maybe I can try to write a code. I think I have already done an import. So standard scaler. I can try to create an object of this class standard scaler, maybe a CLAR or something like that. And I can try to call a scalar dot fit, maybe transform. Why my tab is not working? Fit underscore trans form. Fit transform what? So this new. Okay. So this is our data set that I will be able to get. So this is the scaled data set that we have. Now, if I would like to know the tendency of this data set, so again, I can like get to know about the tendency, that what is our distribution. So whether this data set is normally distributed or not, forming a bell-shaped curve or not, what is the ranges of the data set in between, it is fluctuating. So what I can do is, so maybe I can try to write a code over here to convert these things into a data frame, right? So pandas data frame, and on top of that, so I can try to call profile report. Yes. So after scaling, how my data set looks like. So I'm just trying to find out that. I think we are not doing anything new, right? Over here. Anything new that we are trying to experiment? No, right? It's the same old stuff. I think we all are like aware about it, kind of. So many times we have done that, just a repetitive step. Okay, so now just try to look into this data. So here, column number 1, right, which is nothing but my, I believe, pregnancies column, right? So again, I can try to rename my data frame columns name. As of now, it is given me like this one. So here, toggle details, and now my minimum is this one, my maximum is this one. So this range is very, very closed. Data dispersion is very, very closed. And can I say my standard deviation is equal to 1 now? Yes, my standard deviation is equal to 1. And if I'll talk about my mean, so can I say that it's close to 0? It's a 10 to the power minus 16, right? So 10 to the power minus 16 means it's 0. Should we perform a scalar on entire data set, or first split the computer scalar and train data set and implement? See, again, I think you are talking about a YouTube videos, right, Pankaj, if I'm not wrong. So the thing is, Pankaj is asking me a question that should we perform this scalar things, standard scalar things before doing a trend split or after doing a trend split? So see, again, there is a multiple thought process you will be able to find out, right? With respect to whether we should do it or whether we should not do it. Again, depends upon me. That because see, in a standard scaling, you are just trying to transform your data set on a different scale. So it's completely fine. You will not observe some sort of a data leakage in general. In some of the books or in somewhere, you will be able to get even a suggestion that after train and test split, so we are supposed to scale our data set again. But again, there is a problem you will be able to find out over there. So let's suppose I have done train and test split. I have a different variants of the data set available into a train and into a test split, right? So the scaling data that you will be able to get will be having a different scale for a training and a different scale for a testing. That will create again an issue in terms of our data variances. So you are trying to train your data set, or you're trying to take a trained data set of a different variances and a test data set of a different variances. So that may create an issue. So that is the reason what I generally suggest is that you can try to do scaling things together. It is not going, accuracy wise, it is not going to affect much. You can check. Yeah. So that will be my answer. And yeah, so you can experiment and then you can get to know. So don't go after just YouTube videos. I will suggest you. So last week while testing, we transform a test data set before a testing. Yeah, that's true. By using the same objects, if you remember, right? So hope you are able to get your answer, right? See, it's all about experiment. You will have to, it's not like there is a straightforward answer anyone should give, right? That whether we should do it or whether we should not do it. You are supposed to observe an effect. There is no standard approach in machine learning or in AI, right? So here 1 plus 1 is not going to be 2 at all. 1 plus 1 can be anything, right? So when we believe in those kind of a theory, and when everything is experimental, so at the end of the day, that's the reason. So you as a data scientist is required, right? Because if that is not a case, so in that case, if I'll try to give like a standard steps that do this and then do this, anyone can do it, right? Then why data scientists are required in that case? So we as a data scientist, we always do an experiment, and whichever experiment is working fine, so that we are going to productionize. That's a reality, whether you believe it or not. But yeah, that's something which happens, right? So by doing a standard scaling, will outliers get removed? No, it will be normalized. It will be normalized means, so now it will not give you a very highly skewed things over here. This is something that you will be able to find out. Maybe we can try to even plot. So let's suppose if I would like to see that after doing a standard scaling, so whether we are able to affect my outliers by certain volume or not, right? I think we can do it easily. So I can try to take the previous code, this one, and I can try to take what? I can try to take this data frame, and I can try to plot. Like I said, it's experimental fact. Yeah. So df new CALAR, right? Okay. Execute. And yes, this is something that we are able to get in terms of like outliers, right? That's a result. So it's not like it is we are just trying to like remove the complete outliers by doing a standard scaling, I believe. But so I change the data. Sorry, my bad. Now see, this person has changed. A complete variance of the data set has changed, right? Over here. So that is the data set you are sending to, I would say, to your models, right? So complete dispersion has changed. Now your complete ranges has changed. Now my data set is dispersed. Can I say data set is dispersed equally now? Yes. Between a similar scale, almost approximately similar scale, right? Because if you check the boxes, so almost all the boxes are like coming on a same scale on a y-axis. So data set is in between somewhere -2 to 2, and in this directions. So entire things. Box plot, please paste. I'm not doing anything new over here, so I've just copied a code from the above one. It is fine after treatment of the outliers if we have certain level of outliers like insulin column. Yeah, that's completely fine. So it is not going to affect much. If you have, see, you have to find out the thickness of the outliers, right? So if in a certain range, again and again and again, so you are getting the outliers value. In that case, it is mandatory to treat that one. If your outliers are again scattered and very less, in that case, no need to do outlier treatment. So every time outlier treatment is not required. This is what I understand. Yeah. Okay. So once this part is done, maybe we can try to check a multicollinearity. Yeah. So how we can try to check a multicollinearity? I think we have written a code last time. So we can try to check maybe a multicollinearity of a data set, right? That is possible, or there is a possibility. So maybe we can try to store this data. So after doing a standard scalar, right? After scaling this one, so we can try to store. I think we have not stored this data. So maybe this is the df new. Okay, so I believe I was supposed to pass only x. Okay, so we can try to store this data. So maybe x underscore scale. And now if I'll talk about x underscore scaled, x underscore scale. So yeah, this is the data set that we have. And we have a y data, separate y data set we already have. Okay. Now we have to find out basically VIF. So I think in last class we have already written a code. So anyone who is aware about it? Okay, so Supreet has pinged me that code, right, for finding out a VIF score. Yes. So here we can try to call VIF score. We can try to pass our x underscore scaled, right? Attribute error, ND array object has no attribute column. So what you're trying to pass, by the way, okay, standard scalar you are trying to do by yourself, x dot column, x dot column. Okay, so here this array will go. So what you have done, array dot save column is fine, then array, and then x dot columns of I you are trying to find out, and variance inflation factor, return a data frame. So you are trying to do a standard scaling as well as you are trying to do a this one. Fine, I'll do the same thing. Okay. So here is a VIF score that we are able to find out. Is it fine? So do we have a multicollinearity over here? No, I think we don't have a multicollinearity over here. So are we supposed to remove some of the columns? I believe no, right? We are not supposed to believe anything, because what should be the VIF score if we have to remove or eliminate some of the columns? So can I say that it should be greater than 10? And I think we know the answer. Why greater than 10? So what is the formula for VIF score? 1 by 1 minus R square, right? I think we all know what is the meaning of this R square. And I believe we all have discussed about these things. Why 10, right? It is going to consider more than 90%. That's the reason. So, okay, here VIF score is very low as compared to 10 or maybe even a 50%. So in that case, maybe I can try to make a decision that I don't have to remove it, or I don't have to drop it, right? Okay, any of these things. Now I can try to do one thing. So once we are able to find out these things, now maybe I can try to do a train and test split over here, right? So I can try to call train and test split, which I have already done as an import. And here, so I can try to pass maybe x underscore scale like a standard scale after doing a standard scaling. So I'm trying to pass a data. So test PESD underscore size. Test size is equal to maybe 0.20%. I'm going to keep random underscore state is equals to what? Some number 144, let's suppose. Okay. So this is our train and test split of the data set that we are able to get. So X train, X test, Y train, and y test. This is something that we are able to receive. 80 into 80 to 20 ratio, in which I'm trying to divide the data. So it is going to give me a 4 data set as a return. So maybe in a tuples, as you can see. So I can try to like keep it inside different variable. X train, X test, Y train, Y test. Okay, so fine. X train, X test, Y train, Y test. So these are the data distribution. So X train, X test, Y train, Y test. So can I say that this entire data set is separated, or these two samples has been taken from the same population, which is fluctuating in between the same variances? Yes, because we have just applied a standard scalar on the entire data set, right? So it is coming out of the same fluctuations or maybe a same variations, and that data set. So the data set that we have prepared over here, our test data set. So there is a possibility that I may use this data set for my model validation purposes. So I'll create a model and then I'll try to validate a model that, okay, fine. So whether this thing is fine or not. So there is something called as a model validation that we can try to perform. But this is not the only testing that we perform in general before going ahead with the production. So I think when we will give you a AI ops classes, so in that class, we will be talking about a multiple testing technique as well, because that is very, very important. You have created a model, but your job is not done. Your job has actually started when you're creating the model. So far so forth, it's just a Python code, nothing else, not more than that, right? It was not even like a close to an actual model building. So when you build a very first model, and then after that you do so many things, and that will make your model eligible for a production. So I'm able to build the model, that doesn't mean that I can productionize it. Simple. So we will try to do, or we will try to learn so many different integrated testing things. So how we are going to test it. This test data that you are able to see on the screen is just for the initial verification, nothing more than that, not for the final verification. So if you're saying that I'll test with this test data and then I'll productionize it, no, it is not going to happen. So the final testing will be a random testing. So where I will take a random user data set, and then I will keep on doing a testing on top of those data set, and then I'll try to check a sustainability of my model. So that is completely fine. X-train and X-test, we are able to like split it, right, for my initial model building. And let's suppose I'm going to build a model, logistic regression, LOR, LOGR. Logistic regression model. Now logistic regression, I'm just going to call it, right? And here you will be able to find out a multiple parameter. So in terms of a logistic regression, penalty, dual, total, C is equal to 1, fit intercept, intercept scaling, class weight. So some of these things are, and this is like a LBF, a solver is equal to LBF that we are going to use. Multi-class is equal to auto, right? By default, it will be in a auto mode, even if you are like trying to perform some of the things. And here logistic regression, akka, logit. So this is also called as logit. So logit is nothing but a kind of a functions which will tell you that what is a score for any kind of a data to be available on this side or that side. And this is what we have studied even in our theoretical classes. A log of p by 1 minus p is equal to mx plus c. So that is the logit function that we have studied in our last class, right? So, and here it's mentioned that in multi-class cases, the training algorithm used 1 versus rest. As of now, we are trying to do what? So multi-class, it's now auto mode. So it will be OVO, 1 versus 1. But in case of a multi-class scheme, if the multi-class option is set to OVR, so if you are trying to do a multi-class classification, so in that case, it is not going to be an auto, it is going to be what? OVR. You are supposed to set that as a parameter. This is what it says. So now, and uses the cross entropy loss if the multi-class option is set to a multinomial. So currently the multinomial option is supported only by LBFGS. So this is the solver. So logistic regression solver that we are trying to use by this one, and Saga and Newton CG solver. The class implements regularized logistic regression using linear libraries, Newton CZ, SGA, Saga, and LBFGS. So LBFGS is a solver that we are using. The regulation is applied by default, so you are not supposed to worry about a regularization at all when you're trying to talk about a logistic regression, because it is applicable by default over here. So when we are trying to call this entire things. Now, it can handle both dense and sparse input using a C order or CSR matrices containing a 64-bit of port for optimal performance. So again, optimization and everything. Newton C Saga and LBFGS solver supports only L2 regularization with the primal formulation. So can I say that we are aware about L2, L1? So yesterday, I think some of you, last class, some of you were asking me a question that do we do a regulation over here? So what will be your answer? Can I say, yes, we are doing it by default? And what is our regulation that we are using over here? L2. Agree, everyone? So when you are trying to call this logistic from a scikit-learn, right? By default, this is available or no relation. So L2 relation with the primal function or no relation, the lib linear. If this is the solver, so by default, which solver we are trying to use? We are trying to use this solver. If we are going to use a lib linear solver, again, this is the name of one of the solver, right? By which you can try to segregate or separate a data, right? So that supports L1, L2 regulation both. So depends upon a solver that I'm going to pick and choose with a dual formulation only for a L2 penalty. The elastic net regulation is the only supported by Saga solver. So there is a LBLF solver, there is a Saga solver, there is a SGA solver, there is a libbinary solver. So if we are using a different kind of a solver, so in case of a different kind of a solver, it is going to use a different kind of a realization. So again, in an interview, if someone is asking you a question that does logistic regressions implement a regularization by itself? Yes, it does that. L1, L2, and elastic, all three. But it depends upon the solver that I'm going to use. Solver is nothing but it's a class which has been created, right? And inside that class, these respective regularization has been implemented over here. So Riz, Lasso, Elastic Net, all three is implemented over here. L1, L2, and like Elastic Net. The same relation that we have studied in our linear regression lectures. And I believe we all are aware about a fact that why we are talking about a regularization. What is a role which will be played by a regularization? I think we all are aware about it, right? Yes? Okay, fine. So this is something that you will be able to find out, right? Parameter wise, so these are the parameters and multiple things. So now this is the complete details that you will be able to find out. Now, if I have to read out this complete detail again, so I rather prefer to use this one. So what I will do is, so maybe I can try to go to Google, right? And logistic regressions, right? SQL. I can try to search for that. And here is a complete detail along with a source code, same detail. So whatever we were trying to study over there, right? So by doing like a shift and tab from a doc string, exact same detail, you will be able to find out. See, this is the same detail that we were going through, right? It's the same detail that was implemented. So this is the class, logistic regression class, which is implemented over here. And this is the same detail that we have studied over there. Now here, parameter wise, so all those parameters you will be able to find out. So all these parameters are again a part of your what? So again, a part of your like a doc string, right? So what is a meaning of what kind of a parameter or penalty and like a solver, let's suppose. So this is the solver. So solver means what? Algorithm to use in a optimization problem. So what kind of a solver we are going to use over there. Now for a small data set, liblinear is a good choice, whereas SGA and Saga are faster for the large ones. So it depends. If let's suppose I have a very, very small data set, so I can try to use a liblinear. In that case, this is the class which I can try to, this is the function which I can try to use for my solving my cases, or SAG or Saga if I have a larger data set. So these are the solver which actually calls, or which actually try to implement your complete like a logit function in a different way by implementing a optimizer. Now for a multi-class problem, so only Newton series, Saga, and LBFGS handles a multinomial losses. Linear is limited to only one versus a rest scheme. So more details is again available over here. So if someone is asking me a question that, okay, so whether linear we are supposed to use for a linear solver, we are supposed to use for a multi-class classification, my answer will be no in that case, because linear will be able to handle only what? So it will be able to handle only a, right? So it will be able to handle what? So it will be able to handle only a, this one, binary class classification. So it is not going to handle anything else. So here inside this implementation, you will be able to find out that based on the multiple different kind of a solver, this entire code is written, right? So if solver is equal to linear, multi-class is equal to one versus, like this is just like a code if else kind of a statement which is written over here. Now if you would like to know about this linear more and more, so how linear solver is been implemented, so you can try to look into its original implementation of a linear, which you can find out in a import itself. So let's suppose I'm going to there was a import. Or I can try to do simply it's Python CPPC. Yeah. So here you will be able to find out the exact implementation. So what linear is trying to do. So in terms of reading a data set, in terms of solving, or in terms of linearly classifying or linearly separating your data set, again, coming from the same theoretical example that we have already discussed in our previous classes. So this is again a algorithm inside a algorithm, you can say. So inside a logistic algorithm, logistic regression that we have studied, right? So that was basically a broader view on which we have studied this logistic regression. But inside that, again, there are a multiple approaches which has been followed. So whether it's a linear, or whether it's a LBFS, or maybe whether it's a SAG, or whether it's a Saga. So these are the different algorithms which is been implemented so that it will be able to treat, or it will be able to make a I will be able to utilize a different algorithm inside the algorithm based out of my use cases, and that answer you will be able to find out over here. So depends upon my use cases, whether I'm solving some like an example with a smaller data set or with a larger data set, whether I'm trying to solve something in terms of like a binary class, or maybe with respect to a multi-class, and based out of that we are supposed to select these parameters as well as these equation. So whether it's a Newton CG, whether it's a LBFG JS, or whether it's a linear, or whether it's a SAG or a Saga. Plus So we have to experiment. So let's suppose Newton CG, LBFGS, linear regression, and Saga. So everyone is trying to solve a multi-class classification problem or binary class classification problem, right? But let's suppose I would like to experiment these things with regulation functions of elastic. So we know that Newton CG is available. So inside Newton CG, elastic relation is available. So maybe I can try to experiment with that, right? Then I can try to experiment with L1 and L2. Possible. And then what I will do is, so I can try to test my results. So which one is giving me a best possible and a robust result? Yes. So is this things making sense to everyone? So when I'm talking about a solver, so what is the meaning of a solver over here? Yes. So it's nothing but it's a way of understanding, optimizing a complete process and a data set. So logistic is one of the algorithm, but inside that, in its implementation, so there are multiple implementation or multiple algorithm has been accommodated, right? And again, everyone is going to use a different procedure or different way, depends upon that we are going to search. So best model selection through a grid search. See, we don't do a best model selection through a grid search. We do actually a best parameter tuning or parameter search with the help of grid search. Best model, if you have to select, in that case, AUC is the better matrices. Okay. So maximum iteration. So like how many times you would like to send a data set multi-class. So by default, it's a auto, right? So by default, it will be auto. So in option chooses is OVR, then binary problem is fit for each label. For a multinomial, a loss is minimized. And again, people will ask you like a question that in case of multi-class classification, right? So what is a loss functions that we use? Anyone? So what is a loss functions that we are using in case of a multi-class classification? Okay, so yeah, Bijoy is saying cross entropy. Rest of you are saying softmax, MLE. It will be same as it's one versus rest. Categorical cross entropy. So categorical cross entropy is a correct answer. So when we are talking about a loss function, yeah. So and uses a cross entropy loss if the multi classes, so category cross entropy in general, right? Option is set. So multinomial is option supported by only by this, and this one, this solver. So in case of multi-class classification, so it is always going to use a cross entropy as a function. So again, that is a interview questions that will be asked. Now, if I would like to know that what is a categorical cross entropy, right? So anyhow, we discussed that. So categorical cross entropy loss, easily you will be able to know. So let's try to open up any of the images. And this is a function. So this is basically loss functions that we have over here, right? And if I'm talking about like a cross entropy, so yes. So can I say that this is the kind of a function that we have studied? A loss function that we have studied? Yes. Yeah. So this is the kind of a functions that we have already studied. I think this is the exact formula that we have studied, right? This is the exact formula which has been shared with all of you. So loss function or cost function, right? So this is the categorical cost entropy formula. Please remember it because from the interview perspective, this is important. Apart from this, so not many things is important because now things is clear that by default, it implements a regularization by itself. Solver wise, so there are multiple different kind of a solver. We can try to select a solver based on the data set size, based on the kind of regularization I'm trying to implement, or based on the number of classes that I have. So whether it's a binary class or whether it's a multiple class, based out of that, so we can try to pick and choose any of the solver and then it will work for me. So we are even aware about the fact that in case of a multi-class, it will be OVR. And in that case, we are supposed to set multi-class parameter is equal to OVR. By default, multi-class parameter will be equal to auto. Now, these parameters are very, very important, believe me, right? And all these things will come, or you will be able to remember just out of the experiments. When you will do this experiment 10 times, 20 times, then only. Otherwise, this remembering a parameter for a 10 different algorithm is very, very difficult. But this kind of a questions people ask in an interview directly. Believe me, they do ask these kind of a questions, and it's not tough to remember. So once you will be able to correlate, because base things we already know, right? So we all are aware about like all the base part. Again, these are just a name by which if I'm able to like correlate, for sure I will be able to remember it. Yes. So is this fine till this step? So how many of you have called logistic regression before this class, like maybe some time back? How many of you have called a logistic regression? Okay. So have you looked into these factors, or just called like a logistics and then passed a data into that one? Okay, some of you are saying like yes, and most of you are saying like never even like looked into this one. Yeah, but some of you have looked into that. Believe me, always try to look into these parameters. It will help you out a lot, right? With every algorithms, and try to understand. After some time, you'll find out that almost it's kind of a repetitive parameters we are going to use in most of the places. Yes. Okay, so parameters are important. These are the things which is by which you will be able to build a best algorithm. Generally, what people do is, I have seen this case that they just called like a model, means this objects they used to call pass a data, and then they do like a grid search CV or random search CV or this kind of operations, and by which they try to like a hyper tune, like they try to tune this hyperparameters and all, right? Which is not a good idea. First of all, try to understand, and it's not tough to understand these things, and at least you will be able to remember. So can I say that this solver part is clear? What is the solver? What are all different kind of a solver? Hopefully we are able to remember some of the solver. Yes, you are correct. They asked a lot on this one. Exactly. Yeah, you are going to get a straight question, believe me, in your interview, right? So be ready with this. It's like very, very important for you. So solver is important, right? Maximum number of iterations, so maximum number of times, like we are sending a data inside our algorithm. So at the end of the day, it's a solver, right? I think we are able to understand a multi-class, right? So what is the meaning of verbose? Anyone? Yeah. So informations, or like the things that you would like to display, the internal things that you would like to display, that is something called as verbose. So verbose is a very common parameter you will be able to find out almost in every algorithm. That's a default parameter, right? What is the meaning of n job, number of job? Verbose is a kind of logging. So I think I have recommended you to do a logging in whatever things, whatever code you are going to write. Exactly same way you can try to understand, right? Now, number of jobs. In jobs is nothing but, so let's suppose if I'm using my system and if I have like a core, 16 core and 32 cores, let's suppose I have over here, right? So maybe I don't want to use all this like a 32 logical processor or all the 16 cores, which is available inside my system, right? As you can see. So maybe I can try to restrict it, because there is a case where I have a very, very huge amount of data and I'm trying to do a hyperparameter tuning. It is going to take an hours of time, but I don't want to dedicate all of my resources just for this one. I just would like to control my resources, right? So that system will not feel like exhausted, and it will be able to execute something else as well, because at the end of the day, everything depends upon the like number of CPUs or number of GPUs, number of resources that you are going to give to your program, right? So even that you will be able to control by the help of what? N underscore jobs. This is what it says, that if you don't want to allocate a complete resources, so you can restrict it. So by default, this will be equal to -1. right? -1 means so whatever is available, it will take it. Otherwise, you can try to define n job is equal to 4. So in that means what will be the meaning of 4 or 5 or 6 or 10? Again, depends upon your, so like a number of cores in your system, your machine will be different, my machine will be different, whatever machine you are going to take over a cloud will be different, depends upon what kind of resources you are going to occupy. So number of CPU cores used when parallelizing over a classes if multi-class is equal to OVR. This parameter is ignored when solver is said to be linear, regardless of whether the multi-class specified or not, because like just a binary, right? So like not much resources is required, means one or less parallel in backend. So context -1 means using all the processors. So by default, it will be -1, but if you would like to restrict, you can restrict it. In case of a linear, so by default, it will be using all the processes that you have, all the CPU threads that you have. But in case of maybe a Newton CGF or maybe a Saga, so you can try to control it easily. So -1 means all, whatever is available, it will take it. So whatever will be left, so L1 ratio. So again, you can try to like control all of those things. So all these things, if you will try to read out, it's a very meaningful informations. You will be able, meaningful and real informations, you will be able to find out. So it's not like you should leave this particular part. No, you should always try to look into this particular part so that you will be able to see many different like idea you will be able to generate. Okay. Now, so if you would like to like know more about LBGFS, right, or maybe a linear research paper, the original one. So these, all of these like references are given to you, plus certain set of experiments are given to you. Methods. So what and all methods are available inside this logistic regression scikit-learn implementation. So these are the methods which is available. You can call it and you can try to use it, right? So someone has created the library, so they have created this particular method. So mostly we are going to use fit, we are going to use predict, right? Or maybe predict log priority or predict probability, we can try to print it. So again, if I would like to like know that how this function has been like implemented, whether it's a fit or whether it's something else, so maybe I can try to click on source, and yes, I will get to know that, okay, fine. So this is how this entire functions has been implemented, what it does internally when we are going to call our fit, and when we are talking about like a learning something, so what kind of learnings it is trying to do, which is again a lengthy procedure, but yeah, so you will be able to know about it easily. So yes, these are the outcome implementation is given. So this is right. So whenever you are trying to like read out or trying to implement anything, right, always look into the original libraries. The library version, latest library version that you are using, that will be very helpful for you in long term as well as in short term. Okay, so here I think we are clear on this part, right? Just on this part. So we are trying to call it. If I would like to set some of the parameter, I can try to set it. I don't have any kind of an issue, right? If I don't want to set it, or maybe I can try to set a different solver and this one, and then we can try to check. Okay. So once we are able to call this one, maybe I can try to call this object dot fit is the method, right? And here, so what we are going to fit. So maybe I can try to fit x train. Why this kept? Okay. So X train, I can try to fit over here, and then maybe I can try to fit Y train. And this is something that we are able to get. Verbose is equal to 1. Let's suppose I'm going to set. So I think we are able to get some log, right? Verbose is equal to 1. So we are able to get some log, like I told you. So verbose is responsible for giving you a log over here. So parallel number of job is equal to 1 using a backend, sequential backend with the one concurrent worker, and done 1 out of 1. Elapsed time is equal to this one. So in no time, we are able to finish it. Now, so yeah, so these are just information that I will be able to see, I will be able to get. Maybe I can try to take one data, I can try to pass, and then I can try to check what is the outcome that system is trying to give. So to do that, maybe I can try to call this object. So this object dot maybe predict, right? So object dot predict, and here, so in terms of doing a prediction, so I can just try to pass some of the data. So X test data set I have already created. I can try to take this one of the data, even from a train. For initial testing, I can try to take those data, right? So this is a data set that we have. So maybe we can try to pass this data, and I can try to check a prediction value error y. Data set reshape, single feature, it contains the single one. Yeah. So what is the outcome that we are able to see? So can I say that outcome is equal to 0, means classes is equal to 0. So this is the prediction classes that we are able to receive, right? We are able to receive this one, predict, and then maybe I can try to print a probability. Now, what is, see, I'm just going to show you a couple of things over here. So prediction probability wise, this is like a 0. Okay, where is the mistake? I think I have missed predict, right? So classes wise 0, right? At any point of a time, it is going to predict for both the classes, class 1, class 0, right? So here, what is the probability that it will belongs to class 0? This is the probability. What is the probability that it will belongs to class 1? This is the probability, right? Log probability, or maybe log it if I would like to print. So maybe log R, I can try to print over here, and then predict and log probability. Maybe I can try to pass the same data set. One just a record I can try to pass. And this is the log probability, this side or that side of the line. Log it. Are you able to see my chat? Yes, Janine, I can see your chat. So in the last 10 minutes, you have asked for 20 times for a break, right? You can go and take a break. Generally, I don't respond to those messages. I can see everyone's chat in general. I think that was your question, right? Break. Okay. So here I'm able to predict that, okay, fine. So this data set belongs to which class? We are able to know about it. So here I'm trying to find out the prediction probability, because we have a binary classes, class 0, class 1 we had, right? So for class 0, what is what is the probability? For class 1, what is the probability? So can I say that from here itself we can try to make a conclusion? Yes, that whether my data set belongs to a class 0 or whether my data set belongs to a class 1, right? Easily we can try to make a conclusion over here. And here again, so this is nothing but log it, log of p by 1 minus p, right? That is something that we are able to receive. I think you can even do a calculation out of this one, right? So this is the very neat and clean and clear example or maybe outcome we are able to receive as per our, exactly as per our discussions. So in our discussions, we talked about like finding out the classes, we talked about finding out the probability, we talked about finding out the logits, and yes, things are visible to me. Now let's try to find out that what is its actual y. This is the predicted y, right? This is the predicted y or predicted y probability we are able to get. So what is the actual y? Y underscore test. I believe if I can try to pull out a 0th record. Let me see what is the shape of this one. Okay, so this is a type of this data set is a series. Okay, so here is the things. I can try to get it by 0. Okay, it is taking a default indexes. Fine, no issue. I can solve it. 406 I test. Or maybe I can try to do like a dot ILOC and then of 0. Okay. So what was actual class? So actual class was 1. What is a result which I'm able to receive? So can I say that I'm receiving a result is equal to 0? Maybe we can try to test it for other examples. So maybe for this was for a 0. What is, where is my prediction? So for maybe first record class 0, what is the actual classes? Okay, class 0. So can I say that Here for this record, the predicted one is 0 and even the expected one is 0. So for this one, it is giving me a correct prediction. Yeah, everyone? Yes. So fine, for some of the data sets, so it is giving me a correct prediction. For some of the data set, it is giving me a wrong prediction. Possible. Yes. So yeah, these are the like prediction that we all are able to do. And again, if someone will ask me that what is the prediction probability for these two classes, so here is a prediction probability of these two classes, right? So prediction probability of maybe first record. So this is the prediction probability. So highly it is recommending me to go ahead with the 0 classes instead of going ahead with the class number 1. So that's the exact probability that we all are able to find out. Now it's mentioned clearly over here. So what is the functions that I will be able to see? Yes. So predict, log probability, prediction probability. So predict logarithmic or the probability estimates, predict probability estimates basically, and predict the class level of the sample X. So these are the things that you will be able to find out, right? These are the things that you will be able to see over here, right? Now, if I would like to know, or if I would like to know that, okay, fine, so what and all parameters inbuilt or default parameter it has taken, I think I can print that as well. But that can be visible even by doing shift and like a tab. And these are the by default parameter that has been given to you. Maybe we can try to change some of the solver over here. So instead of using this LBFGS solver, right, I can maybe try to use this one, liblinear, maybe. There is a possibility. I can try to use liblinear over here. So this is a solver if I'm going to use, because that will be a, yeah. So can I say that liblinear is also giving me the same result? Maybe I can try to build two different models here. So this underscore liblinear, right? And yeah, so just fit it. And another I can try to build over here, which can be a default one, LBFS. Okay, so this is the default one, right? Okay. So I can try to build in both the places. I'm just trying to do a verbose and log gr dot fit. I can try to write x underscore train and then y underscore like a train, right? So this is the model. Now maybe I can try to check that what is the accuracy that we are getting, right? So what is the accuracy that we are getting out of like these two models? So what is the actual accuracy? So if I have to find out the accuracy, what is something I have to do? Yeah, I'm just trying to compare, right? I'm just trying to compare what? So I'm just trying to compare same logistic regression, but inside that there is a liblinear solver and there is a like a LBFS solver. So I'm just trying to do this kind of a things. Now here, so what I can do is if I have to check what is basically like accuracy that we are able to receive. So which one is giving me a better accuracy? So whether this accuracy is given by, right? So accuracy given by a liblinear is better, or maybe a default one which is nothing but LBFS is a better. So how I will be able to estimate that? Because see, we have two models now. One by using a liblinear inside a linear logistic itself, and one is by using a LBFS. Out of these two models, I have to select the best one. So what will be my procedure? What should be my procedure to do that? No, so first of all, I have to find out the accuracy, right? Many of you are suggesting AUC, ROC, I think based on my given definition. Right? So you people are straight away saying that, okay, I'll go ahead with AUC, ROC, but before that confusion matrices, you will have to find out, right? Confusion matrices you will try to find out, then you will try to check the accuracy, then maybe you can try to go ahead with the like F1 score, precision, recall, sensitivity, all those things, right? So the first idea and everything depends upon what a confusion matrices. Even your ROC depends upon that one, yeah, and plus threshold. Agree? So my first idea over here should be to plot or print maybe a confusion matrices. Agree, everyone? Yeah. Okay. So if we have to, yeah, if that is the idea, so that's completely fine. I have built two models. One is this log R, which is the default one, and one is the liblinear, which I have built over here. So liblinear I have built over here in this particular place. Fine, I can call both the objects over here. So one is this one, and one is log R. Yeah. So one is this one, and one is a log R, which I am able to build. And just wait, guys. So at the end of this class, I'm going to give you again a task, a very good one, so that you will see many things out of this one. So again, liblinear and log R. Now here, I can try to do maybe a log R liblinear dot predict, and here we can try to pass the entire test data, let's suppose, right? So can I say that it is going to give me y pred for all the data? The regression instance is not fitted yet. Okay, I think I have not called a fit, I believe. Okay, yeah, I have not called a fit. So I think I should call a fit. So liblinear.predict. So fine, y prediction we are able to get. Let me rename this thing. So y prediction from liblinear. Y prediction for liblinear we are able to get. Okay, this is the prediction. Now y prediction from, I can say maybe default one is going to be what? So this is my equation, and then I can try to pass a X test. Logistic regression object is not callable, is it? Why? Okay, dot predict, right? Okay, so from default, this is something that we are able to get. So this is a result from a liblinear, and this is the result from the LBFS, right? Okay. Now, if I have to draw a confusion matrices, right? So if I have to draw a confusion matrices over here, confusion matrix, I have already done an import of it. So here I can try to pass what? Y test, comma, Y pred. So Y pred for liblinear. So this is the confusion matrix that we are able to get for a liblinear, right? And the same thing we can try to repeat over here. We just have to change this one to default. So this is the confusion matrices that we are able to see from this one. Now, can I say that by looking into this confusion matrices, it's same? Yes? Okay. Now, in between, so Baba has helped me out, and he has given me one function. So where I can try to pass a Y test and Y prediction, and I will be able to print, right? So I will be able to print accuracy, precision, recall, specificity, each and everything. So this is the function pinged by Baba to me, right? So this is the functions that I have received from a Babel. So fine, no issue. Let's try to do that. So I can try to call this model evaluation over here, and model evaluation, I can try to pass model evaluation out of liblinear, right? Fine. So accuracy, this one, and maybe I can try to do a model evaluation even for predict default, right? Okay. So can I say that both is exact same? There is no differences. Again, confusion matrix itself was same. So can I say that we are able to print accuracy, right? So what is the accuracy? This plus this divided by all four, right? For both the models, we are able to call the precision. We are able to call the recall. We are able to print the specificity. Agree, everyone? Yeah. please use classification report to use everything. Yes, I can try to use it. That's not in case. That is fine, right? So can I say that we are able to print each and everything over here? Yes. So now accuracy wise, I think you have made some mistake. True positive, true negative, true positive. I think he has made some mistake. See, accuracy should not be 1.23. I think Baba has made a little mistake. So true positive plus true negative divided by true positive and true negative, false positive, false negative. This is the accuracy. Okay. So accuracy is equal to 74%. We can check all other formula. I think we all are aware about formula, right? This is the like a function written by Baba. So he may have made little bit of mistake. Every one of us gets confused like when we talk about these things. So that is completely fine. You can check a formula, you can cross verify, right? So can I say that this is the accuracy that I'm able to receive? Yes. So is this things fine to everyone? Ping the code, please. Don't worry. The entire code will be available inside your dashboard, right? As of now, either you can type or you can try to understand. I think that will be a good idea. Okay, so precision we are able to find out, recall we are able to find out, right? Can I say that I can try to find out even F1 score? So if someone is telling me that, can you please try to find out an F1 score? So yes, I can try to find out F1 score. So it will be nothing but recall. So recall into precision. Just I have to change this variable. So recall precision. Recall, I can try to change over here, right? And here F1 is equal to F1 score. Yes. So I'm able to get like a F1 score as well. Yes. So all the metrics, accuracy, precision, recall, specificity, F1 scores, everything we are able to find out in this particular place. Now, what is area under the curve? AUC, right? I will be able to get. So again, if you will if you remember, so I have already done an import of AUC ROC in a very beginning itself, and I think you all have done that, right? So maybe I can try to pass. I have to select one model out of these two. So ROC AUC for lib linear is this one, right? And ROC AUC for this one. Both is same. Yes. Yeah. So even AUC we are able to like print over here easily. We all are able to like print AUC this one like AUC. It's like very easy to print these kind of things, right? So easily we can try to print it. Again, if we have to print an ROC, so maybe I can try to call ROC curve. ROC curve I can try to call, and I can try to just like give this one. And these are the three things you will be able to find out. So one is a FPR, another one is a TPR, and another one is a threshold. So these are the three outcomes that you will be able to receive. So like what was the FPR, what was the TPR, and what was the threshold value which was given to you. And if you would like to like plot entire graph, so you can try to plot it. FPR is not defined. So let me change this one to FPR. AUC is not defined. So ROC AUC score I'm able to find out. So this will be AUC. So AUC is done. FPR is done. Yeah. So this is the graph by which we are able to find out what is ROC, and we are able to find out what is the ROC curve area, which is consisting of 69%. And exactly this is the same result that we are able to see. So we are able to find out even our ROC, and we are able to find out our this one. So is it fine? Again, you can check for both the models. So that's completely fine. Whichever is giving you a maximum AUC, so you will try to select that particular model. So AUC is finally giving you an area. Can both model predicts differently if confusion matrices is not same? Yes, that's true, because true positive rate and false positive rate depends upon your confusion matrices, right? So false positive rate is nothing but 1 minus specificity. So is this things fine to everyone? We are able to build the model. We are able to compare things. We are able to build a multiple logistics model. You can try ahead with other solvers. Maybe you can try out with all the solvers that we have, because every solver is using a different things, right? Please show AUC. So my AUC is this one. So simple ROC AUC curve you have to call. This is the method you have to call. ROC AUC score, right? So are you all able to digest this one? It's a good idea to plot AUC of both the model in the same graph. See, even if you are not plotting a graph, right, you are able to get a very clear answer over here itself. So wherever I'm calling this AUC ROC, so it is going to give you a very exact like a area between 0 to 1, it will give you. So even from here, so you can do a comparison. So which is the maximum? So that model will be selected. Don't watch a recorded session. No, I think थोड़ा time लगेगा digest करने में, practice के साथ हो जाए. Okay, a few things went over the head. Which one? Naveen, which one went over your head? As need to listen again and apply it. Easier to digest than theory classes. Yeah, so this one is easier actually as compared to theory classes. So this one is easier, I feel. Final model selection, AUC. See, if you are building a multiple models, then in that case, that's the reason so I have shown you lib linear as well as default one. So I'll give you one task. If you're able to complete this task, you will be able to remember everything for next 1 or 2 years. So for sure. तो समझ आ गया, पता नहीं याद रहेगा नहीं. That's the reason I'm going to give you one task. Already have a task. I'm aware about it. You already have a task. Let's take this task. That this task is like a smaller than. Again, some of you have already done even a submission of DVC and MLOps just within a week. Even today, I have received some of you, a couple of the mails from your side. Yeah. Depends how your theory class when I'm not able to get this feedback or no. I believe watching theory class after this Python class will give even a better understanding. Yes, for sure. अभी हेल्प समझ सबमिट कर दिया. मैं तो अभी हेल्प समझ ही रहा हूँ कैसे सबमिट कर दिया. Yeah, so there are people who have done the submission, Sarad. So need to revise it again. But whatever theoretically we have discussed, are we able to call it or not? That's my question. Can you please explain a Cook's distance? See, in this way, there are so many ways, so many approaches. So generally, when I explain some of the algorithms, I keep on changing my approach. It's not like in every algorithm, I'll just use the same approach. So I think many things will be discussed in this way. I see a live class, I don't understand, but when I watch again, implement it, I understand it. Yeah. Yes, I have sent you a resume automation project. Yeah, Vivek, I have seen your mail. I'm aware about it. I'm yet to reply because I have not checked your GitHub. So I just seen your link, and because of the time constraints, I was not able to check. So once I'll check, you'll get a response. Today, it's I think you have sent me a mail. Theory made easy to digest this code. Exactly, yeah. Theory made easy to digest a code. Coding is nothing. So whatever we learn in a theory, because someone has already created a classes, libraries, and functions for us. So we are not supposed to worry about the theoretical part. Yeah. Now, are we ready for a task? We'll take maybe a 5-minute of break, a very quick break of 5 minutes, because I know most of you are feeling exhausted, right? Back to back 2.5 hours. So we can take a break. I'll take another 15 minutes, 5-minute of break, just 5 minutes of break. Then 15 minutes I'll take to explain you your next task. related to this algorithm so that you will not be able to forget this algorithm. That's the reason so I'm giving you that task. Okay, so I think some of you are feeling like exhausted. So take a break, guys. 5 minute, quick 5 minute break, not more than that. Quick 5 minute. Come back, take a task, and then end the class. Okay. So yeah, take a break. So it's now 5:30. By 5:35 or 5:36, we'll resume again, and I'll be talking about a task. Okay, just 5 minutes. After that, point break for today. Okay, so I think we are back after a quick break, right? All of us. So are we back? Okay, Anubja, so it's a good idea if you are completing your recording. That's fine. That's fine. You can go ahead with your own pace. Akshat, reply नहीं कर रहे हैं आप. I think I'm replying to everyone. Don't you get exhausted? There is no option available for me. For Zoom issue, I'll try to look into this soon. My task is in progress. Please tell me ROCAUCS score is coming. 1, is it fine? ROCS score, AUCS score is coming 1. So in that case, your model is giving you 100% accuracy, which is not good. Because with respect to any data set, it should not give you this 100% accuracy. Will you make this notebook available today? I'll just ask my team to share these things in your dashboard quickly, as quick as possible, right after this class. Break it just for 4 minutes. A question, okay. Please address this question. What is your question, by the way? I'm lagging behind internship. No issue. I think first of all, try to understand our core things, right? And then when we'll start talking about the project, because the project recording which is available inside your dashboard, right? So I have a plan to change that project as well. So this time, when we will go to the project, so let's suppose there is a wafer fault detection, there is a Fitbit dataset project which is available inside your dashboard. So a project will be discussed this time in a complete different way. So the kind of a recording that you have inside your dashboard and the kind of the way we are going to discuss, because this time, so we will try to build a project by using a complete ops part as well, plus Docker, plus Kubernetes, plus cloud, right? So complete platform wise project, I think we are going to discuss in your batch for the very first time. So that is, and by the time, so we'll reach out to the project. After that, you will, if you will touch your internship project in between. So yeah, just keep on doing your internship things, whatever work that you are able to do, so that you will be able to build your base at least, right? Because that is very, very important, building a base. But when I'll discuss a project in your batch in a complete different way, the way we have not discussed it yet, because this time I have even changed that part, especially for your batch, FSDS batch, right? Because personally, I'm taking care of all of your classes and everything. So I think we'll achieve this time a new heights. Already those projects are heavy projects, but this time it will be discussed in even in a much, much better way, in a way that we create a platform in that way, exact that way. So even scheduler will be available. Even Dockers will be available. Kubernetes containers will be available. Cloud will be available. Ops part will be available. Model retraining will be available, which was not available in the previous projects, for which recording is available inside your dashboard. So that is my idea. So as soon as we will try to reach out to this clustering part, right? After discussing approximately, I think 10, 12 algorithm more. So we'll start our project in this way, so that we will not leave even a single thing unturned, whether it's a model retraining, because nowadays I have seen a trend in a market that people have started talking about ops part, that what is the ops stack of your project, what is the retraining approaches, what is a scheduler, again, along with the databases, along with the platforms. So nowadays, this kind of a things is like a pretty much common, and we as a iNeuron, so keep on adopting a new things for sure. So that's a like a way I have like a plan. I already have those kind of projects. I have like hundreds of such kind of projects. So I'll just start from your batches. It will be a little bit tough even for me to discuss, right? But yeah, so DVC, MLOps, everything will come over there itself. So that's the reason. So we are like, I'm giving you this many number of tasks so that you guys will be ready, because in projects, there will be like a 20,000 line of a code. And that point of a time, it won't be possible even for anyone to talk about each and every line of a code. There are so many modules are available just in a single project, right? Even authentication, securities, everything is available. So we are building a base for that one, because that is our final objective. This is not our objective. This is just a path that we are trying to follow. That's it. So hope you all are able to understand my idea. When you are going to discuss that, after talking about a clustering approach, because clustering, classification, and regression, all these things will come together in a single project itself. You have a general level that. Okay. Yeah, Pratik. What is scheduler? Don't worry. When I'll discuss, right, scheduler plays always a very, very important role in a production. Ops part plays again a very, very important role in a production. Retraining approach plays a very important part in production. So, like I said, model building is just a starting point. It's not an end point, right? So, this one. We will cover time series also. Yeah, for sure. Time series was like a part of your chapter. So if I'll skip, you will drop hundreds of mail, right? So I have to avoid your hundreds of mails. So I'll have to discuss time series. What about PCA? Even PCA is a part of your syllabus. So I don't like getting those mails, right? Saying that you have not discussed that, you have not discussed this. So I'll discuss. Okay, I think my screen is visible. Now let's talk about a task. Loves PCA. Yeah, PCA, I think in night 8 p.m. batches, I have discussed that this time in a complete different way. So, yeah, again, in your batches, I'll discuss in the same way. Okay, so now let's talk about task. So, task wise, I have a data set over here, right? I have a data set over here, and this data set is a little different as compared to a data set that we generally receive. And let me open up official repo of this data. Yeah, got it. Okay, so this is a data set which I have downloaded. I'll just give you an explanation and task about this data set. So if you will go to this data folder and you can download this zip, this link will be available inside your dashboard. So don't worry about the link. Just try to understand what is a task. So once you will download this one, this data set, so you will be able to see and download and unzip it. So you will be able to see so many folders over here. Bending 1, bending 2, cycling, lying, sitting, standing, and walking, right? So these are the folders you will be able to find out inside zip. Along with that, so you will be able to find out this PDF, right? So inside this PDF, so there are like notes, node number 1, 2, 3, and plus there is another PDF of bending. You will be able to find out bending 1 and bending 2. Now, so people have captured this data set for a different positions, right? So for like 1, 2, 3, 4, 5, 6, 7, for a 7 different position of a human being, right? So people have captured a different kind of a records, a different kind of a data set out of this one. Now, if I'll try to click on walking, right? Inside walking, there are multiple data set which is available. Now, if I'll try to click on standing, again, multiple data sets are available. If I'll try to click on sitting, again, multiple data sets are available. If I'll try to click on lying, again, multiple data sets are available. So for every folder, you will be able to find out, right, a multiple different kind of a data set, or maybe you will be able to find out a different like files, a CSV file or Excel file in this particular place. Now let's suppose inside a line, so I'm trying to open up one of the sheet. So this is how your sheet looks like. Inside this sheet, you will be able to find out a frequency, clock, duration, and column time. And plus, you will be able to find out like an average RSS or where RSS, average RSS, again, RSS 12, RSS 2, RSS 12, RSS 13, RSS 23. So these are the metrics or these are the parameters. So now nature of all of this data set is same. This is the classification problem, multi-class classification problem that you will have to solve. Now, let's suppose if I'm looking into, right? Let's suppose I'm looking into this lying data set. So for all of this data set, what will be my class? So my class will be actually a line. So here inside this data set, classes are not given. Here you have to create a column called as label. And then let's suppose I'm trying to import this data set from a line folder. So line. This will be your basically this is going to be your complete label. So you have to create a labels manually based on the folder from which you are trying to take this data. So similarly, let's suppose if I'm going inside a cycling, right? And then if I'm trying to open up this data. So from a cycling, if you are trying to open up this data, so again, you will have to create a labels. Let me close my notebook, right? So from cycling, if you are trying to open up this data, so again, you will be able to find out like RSS 12, 12, 13, 13, then 23, 23. And this data set I have copied from where? So this data set I'm trying to take from the cycling tab, right? So from the cycling tab. So here there are so many files, not just only one file. So inside cycling, multiple files, inside lying, multiple files, bending 1, bending 2, sitting, standing, walking. So we have a multiple files available over here. So very first thing is create a labels. Now, so you have to write a Python program, Python code. So my expectation is write a Python code, and that Python code will try to read a folder name, and that it will go inside that folder, whatever files are available. So it will create a label column. Before that, for sure, you will have to remove some of the things. So let's suppose if I'm going over here, so there are these 3 things which is available, right? We don't need these things actually, right? We don't need these things. So we have to remove these things. So again, you have to perform these things in an automated way. There are hundreds of files I have given to you. Now, don't do these things like open up all the hundreds file, then remove or delete this one, right? Delete this one, and then manually try to create what? So manually try to create our labels over here. No manual approaches will be appreciated at all, right? So everything you are, because we all are aware about the Python things, right? We all have done much more complex tasks in a Python. So LE, let's suppose I'm going to create, and this is the data set which I have copied from cycling or maybe like a line or something. So this labels, so cycling, and then so labels for all of this data set will be cycling. So now you have a labels available to you. Now the problem is I have a multiple things, right? I have a multiple files over here. So everything should happen in an automated way. Are you able to get this one? First of all. So how you are supposed to create the data, and what is the nature of the data, or what is the structure of the data set which is given to you? Yes. Now, once you will be able to do that, you have a multiple classes. This is not a binary class I'm talking about. 1, 2, 3, 4, 5, 6, 7. So in total, you have 7 number of classes. So can I say that this is the multi-class problem that we are trying to solve? Yes. So this is a 7-class problem, right? This is the 7-class problem. So you have in total 7 classes. You have a multi-classes. As of now, I have not discussed any other algorithm except logistic regression for a classification. So a restriction over here is that you are not supposed to use any other algorithm, even if you are aware about it, except a logistic regression. That's a restriction on you, right? Because I have not discussed these things. So I don't want you to implement it. Very simple. This is the task just with respect to a logistic regression. So try to build a model. When you are building a model at that point of a time, my expectation from your side, my side will be that try to use a different solver over here. We have a Newton solver. We have a LBFS solver. We have a liblinear, which is not applicable in this case. We have a SAG. We have a Saga. So try to utilize a different solver over here. try to get a best possible outcome, and then give me a final model. So you have to use at the end of the day AUC score to finalize a model. And then in between, so whatever permutation combinations and EDA you can perform, I'm just leaving these things up to you, right? So here, if you will go to this repository, so here you will be able to get a very clear idea and understanding that what is your input or what is your target and what is your feature data. Same explanation which I have given to you, right? Exact same explanation is available even over here. So you can, I will upload this link itself from where you can get a data set. You can get even a data set descriptions, but I believe data set descriptions I have already provided it to you. So you can try to work accordingly. And whether it's a worst model or a best model, you have to give me. Simple. Yes. So this link I'm going to share now, and after this class, so the same link will be available even inside your dashboard. Is it making sense? And I think Akshat has documented this entire task, right? So this is the task which you have to complete. In this way, you will end up revising each and everything. EDA will be covered automatically with respect to this data. Nature of this data set is different. So this is not just a flat file that we are taking. So you have to work even on a data part, right? In your seat. So there are some extra data, extra like a rows, which is available. So you will have to work even over there on those part. Yes. And then you have to create one final data set. So I think you have to merge it, right? There are hundreds of files that you will have to merge it, and then you will be able to create a final data. Everything should happen by code. No manual intervention after downloading this one. Is it making sense? So what is the task deadline? I'm just leaving up to you because I have already given you a task, and next week, I believe it's a deadline for that task, DVC or ML ops or both, right? So that is a deadline. So you can take your time, and I think this task will not take much time. Here you just have to write a code, simple. So you can start like working on it, right? And maybe try to submit it by next week. And then after a next week, so I will take 1 week of time, one complete week of time, because so far I have given you so many tasks. Most of you are able to complete it. Some of you are not able to complete it. And yes, so you have sent me a mail. So after next week, not this week, after next week, I'll take a classes, Saturday, Sunday classes I'll take. So in total, 3 classes after today I'll take. And then in between a weekdays, right? So I'll invite every one of you. So those who would like to discuss or talk about the solution, including either a DVC, ML of this task, or whatever task I have given to you, starting from the beginning, right? So whatever task, so I'll just send you a form, whatever task you would like to discuss, right? So you can discuss about those tasks. You try to explain those tasks to everyone in a class. They can ask you any kind of a questions, right? So that will be just depends upon the interest. Again, that's the reason. So we are going to keep it in a weekdays, right? Weekdays after evening 8 or 9 p.m. So from my side, if possible, I'll join. Otherwise, someone from my team will join, because there we don't have to do anything. We just have to host you all, right? So that you can share your screen and then you can try to talk about it, because it will be your classes. So after that, we will share the code, so that your work will be available to all of them. So those who are not able to do it, even they will be able to do it, right? So is it fine? Please take it out 9 if possible. Yeah, we'll try to do it. Like again, there is a very like a high chance that I won't be able to join, because I have already seen your mails and everything. I have approved all of your like a task over a mail, right? So someone from my team will join. But what I believe is, in this way, things will be beneficial, and those who are not able to complete a task, so yes, they will be able to understand it. They will be able to complete it. Plus, you will be able to get a even code. But after that, fine. And whatever procedure, whatever standards that we have defined during our Python lectures, all those procedure and instructions are applicable with any of my tasks, even if I'm not going to say. Yes, Tahu, I think Kitiz, right? So you are able to get your answer. So by default, those things are applicable. Logging and all those things which I told you, modular coding, classes and objects, right? So by default. You're not even supposed to ask that whether it's applicable or not. It's applicable by default. So hope you will enjoy this task, right? Right after this, DVC comes under MLOps or it's a different area. DVC comes under MLOps actually. DVC, ML flow, all those things comes under MLOps. Okay. So fine, guys. See you again tomorrow. Tomorrow I'm going to start a new algorithm, by the way, and in between. So try to complete this task, and then back to back, we'll look into the deployment. So once we'll because we have already seen a deployment in Azure, AWS, I believe, and Heroku and GCP. I think we have not done that, but we'll do it, right? And yeah. So as per your syllabus, I'll discuss algorithms into tomorrow's class. Yes. Please upload notebook as early as possible. I'll just provide these things to my team. Let's see how soon they are going to upload it. I'll just ask them, like, do it immediately. Let me do that one. And even link will be available. Yeah, so logistic regression implementation. And guys, shall I do one thing? So in the same logistic regression implementation, so shall I mention in the same notebook itself so that we'll not have to upload multiple files. So shall I update our links inside the same one? Logistic regression task. So let me show you that, right? So I'm just going to mention in this way. This is the notebook, so which will be uploaded, and in the same one, so logistic regression task wise, I'm going to update a data link. So this is a data link, so you can open up this notebook, you will be able to find it out, right? So no need to look into multiple unnecessary links or something. And this is the write-ups given by Akshar. So again, I'm going to mention this write-ups. Is it fine? So this notebook will be available in some time inside your dashboard. Fine, right? Yeah. So don't come and ask me that where is the link and all those things. I'm not going to upload a link separately. It is available here itself. You can have a look into it. Yes. Okay, so with that, Mano Ojha, I think you should connect with the support, or maybe you can come to a doubt clearing. That will be resolved automatically. I think we have already resolved for many of us. Also, my kind of request, please, could you please tell me your team to save this chat transcript in text and FATS web page? No, that won't be possible because it's like so many batches we used to take, right? So that I'm really very sorry about it. Now you said upload a recording of AOps in our dashboard. It's not been uploaded. Yeah, I have given you a task, right? First complete a task. Upload wise, our team can upload it within 5 minutes. We have a recording. Classes are already going on, right? I think you all are aware about it. But something I'm expecting from you on your side. Okay, so fine, guys. I'm going to share this Jupyter notebook inside your dashboard. I'll just ask my team to upload it. Yeah, sent to my team and they will do that in full in some time. Yeah. So fine, guys, with that, thank you so much. See you again in tomorrow's class. Tomorrow we are going to start ahead with a new algorithm as per a sequence of your dashboard. So whatever comes in between, and then we'll try to do so many experiments over there. With that, thank you so much. Let us set, do we need to predict which exercise person need to? So in data set, do we need to predict? Yeah, for sure, right? From the same data sets, we can try to divide. We can try to keep a separate data set for the prediction. Yes, Sivansh, you can mention that. Okay. So with that, thank you so much. Hope you have learned something today, right? And yes, you will be able to learn in upcoming classes as well. Is a decision tree you are going to teach tomorrow? I think it's a decision tree. I don't remember. So sequence wise, I'll try to go. Yeah. Okay. So have a great night ahead. Thank you so much.